Hello, can you guys hear me? Hello. Hi everyone, how are we doing today? Hello guys. Hello everyone. You highly welcome to today's event. So today's seminar, today's study series is Introduction to Azure Virtual Network. And we have no other speaker than our speaker Barry. Hi Barry, can you hear me? Hello Barry, can you hear me? Hello. Hello Barry, can you hear me? Please, guys, if you guys can hear me, could you give me a thumbs up or just give me a reaction that you guys can hear me so we can continue? Hello, anyone? Hello, everyone. Can you guys hear me? Hi, Barry. Can you hear me?
Can you hear me?
Sure. Yes, Barry. I can hear you now.
Yes, I can hear you. Can you hear me too?
Perfectly. I can hear you right now.
Can you hear me?
Sure, I can hear you.
Oh, okay. Fine then. I think it's the headset. All right. Can Okay. Yeah, it's fine.
Okay, once again, hello, everyone. How are we doing? Um, I'm saying hi to everyone from here. How has your weekend been? We trust you're doing great. And today we're bringing you a very special study series. The study series we're bringing to you, we all know that each and every one of us, why in the cloud, why have deploying one or two resources in the cloud, we know that we always have to use Azure Virtual Network. Network is a very vital topic that no matter whatever you're deploying, you will definitely need a network. So we're bringing to you this study series on networking, Azure networking. You all know that networking is the backbone of any cloud infrastructure. So that's why we are here to give you the fundamental of networking so that you'll be able to deploy your infrastructure very well. And on this today's topic is going to be introduction to Azure Virtual Networks. So on this introduction to Azure Virtual Network, we have a very well experienced speaker today, Barry. Barry has over 10 years experience in field of networking as well as SOT, architecture, he has architect multiple cloud and zero trust solutions. So he has guided organization through complex security transformation, and his work spans through IDS slash IPS slash PAMS, WAF, NGFW and beyond. So it's always aligned with technology investment with measurable business outcome. So I can tell you that Barry is the right person for us today. He's going to take us through his vast knowledge of networking. He's taking us through our introduction to Azure networking tonight. Hi Barry, you can have the floor.
All right. Thank you, Kathy. I'm so honored to be here to have this session with everyone. Um, to, this evening, we'll be looking at an introduction to Azure networking, and we'll be spending the time to see what Azure networking is all about, and again, to delve into IP addressing for us to have deep understanding on IP addressing. So without further ado, let's get into the class, right? Yeah. Okay, just to confirm, I believe we can all see my screen. That's good. All right. So the overview of today's class will be looking at how to implement Azure Virtual Networks. We'll be looking at how to configure public IP address services. We'll be looking at designing and implementing name resolution, designing and implementing cross VNets connectivity, implementing virtual network routing, and Azure Virtual Network NAT also. So we have lots to do today, and I want to believe a lot of you are set to get the best out of the class, right? So outside the fact that we'll be looking at the Azure resources and the Azure implementation, the concept of IP addressing is quite a broad one that will spend some good number of time to address that, to focus on that, so that we have good understanding on what IP addressing and IP planning is all about, right? So exploring Azure Virtual Networks. So in here, we'll be looking at the capabilities, the various capabilities of Azure Virtual Networks. We'll be looking at virtual networks address space, subnetting, private IP address allocation, how to create a virtual network, and then we do a demonstration. So this more or less like the overview of the first module that we'll be looking at, right? So what is so just to give a background, right? How does Azure get to communicate? What is Azure network essentially? What are the type of communication that you can experience when you are on Azure, right? So a typical example, just three that you see here right now, is one, with Azure, you can have communication with different Azure resources, right? From one resource to another resource, you can establish connectivity between the two of them, and then you are able to pass out data, you are able to pass out information, you are able to carry out effective networking just using Azure resources, right? Then outside you communicating with Azure resources, there is also you communicating over the internet, right? Or to the internet. So for example, the resources you create on Azure, some of them will need internet access, all right? Some of them will need users to be able to come in through the internet to be able to consume whatever resource or application that you have designed for others to partake of, right? Then there is the on-prem networks also. Now, so that you are in the cloud, your resources are in the cloud, it doesn't just end there, right? You can also, with Azure networks, establish connectivity between your on-prem resources or your on-prem network with your cloud networks, right? So these are the different types of communications you can experience in Azure. So it's either you are communicating with Azure resources, which is just in the cloud, right? It's not going out, just resources to resources. That can be established, right? And which is almost a given using Azure networks. Then there is also you communicating to the internet, or those in the internet having to consume your resource that is already in the cloud, right? So that is also a form of communication. And then lastly, when you have your resources on-prem, probably you have your head office on-prem, you have your infrastructure, some infrastructure on-prem, and yet you have some also in the cloud, and then you want to establish connectivity between these two. And these are the various forms of communications that we'll be looking at in Azure. Now, talking about the capabilities of Azure Virtual Networks, what are the things Azure Network can deliver for you? What are the things that you can experience when you are working with Azure networks, right? So you can have communication with the internet, just like we established previously as the type of communications you get to have. So, right, you can have communication to the internet. All your resources by default have access to the internet, right? By default, they have like an outbound communication to the internet. They can easily just reach out, right? But to have a return traffic is where you will need one form of Azure configuration or the other, right? But by default, whatever resource that you spin up on Azure, so long you are assigning a VNet to it, so long you are assigning an IP address to it, right, you automatically have access to the internet on that resource. But your inbound communication then will be a function of either you have a public IP address or a load balancer. So by default on Azure, you have internet access by default, all your resources, so long it belongs to a VNet, right? So that is one capabilities that you see once you spin up any resource on a VNet on Azure. Then the next is communication between Azure resources. Once you have a VNet, once you have a service endpoint or a VNet pairing, you can establish communication with any Azure resource on Azure, right? With these three resources, you can get to establish communication with different form of resources on Azure without having to worry your mind too much, right? So probably you have service endpoints that you want to establish communications with, right? You can, with Azure resources or with VNet, Azure VNet, establish that kind of communication. The same way with pairing, probably you have different subscriptions, or probably you have resources in different regions, and then you want to use like a private communication channel. Then you can then use, as against having to go through over the internet, you can use the VNet pairing to get to establish that. Now, another capabilities of Azure Virtual Network is your ability to communicate with your resources on-prem, right? That you have your resources on-prem and then you have some of them also in the cloud. You are not totally you are not totally, you don't need to be totally isolated, right? You can have a situation where you have your some resources on-prem and you have some resources in the cloud, and then you set up more or less like a hybrid network between the two of them using these different resources, like your point-to-site VPN, your site-to-site VPN, and Azure Express Route, to be able to establish that communication between your on-prem resource and then your cloud resource, so that you are deploying resources in the cloud does not isolates you from establishing or making use or consuming your resources that you have even on-prem. So with site-to-site VPN, or probably let me start with point-to-site VPN. Point-to-site VPN talks about probably you have like a work from home or work from anywhere scenario, right? And then your end users can from anywhere log into their or consume their resources in the cloud right from their laptop, even if they are not in the corporate network. So we point to site VPN. They can establish VPN from their systems, from their PCs, from wherever they are, into the cloud and consume your resources over there in the cloud. So you don't necessarily need to have your people isolated simply because you have your resources in the cloud. And they don't also need to use the public internet to be able to get access into your Azure resource. With point-to-site VPN, your end users can directly connect to Azure to consume whatever resources you have up there. So the same thing with site-to-site VPN. Site-to-site VPN speaks about when your corporate network, the full corporate network, you want to have the full network, right, established between your on-prem office, your headquarters or something, right, with Azure. So at that moment, it's no longer just a single system, it's the entire corporate network that is connected to Azure as an entity. So with that, you have like a bilateral communication between your on-prem and your cloud resource almost as if the two of them are either on-prem together or they are both right on sites together. Then Azure Express Route is Azure's dedicated private communication channel, right, that users can also make use of as against having to go through the public cloud. So you can establish connectivity between different sites and different locations, or even different Azure resources using the express route, which is totally different from having to go through the internet. So it gives you more bandwidth, and it gives you more privacy when you use the Azure Express route. Going further, we still have more capabilities from Azure Virtual Networks. We see Azure being able to establish filtering, right? So even as you are deploying your resources on the VNet, you're deploying your resources on the cloud, security is also a key aspect of all these that we are talking about, right? And with Azure Virtual Network, you can filter your traffic using either the network security groups, or you use your network virtual appliances, right? So virtual network appliances like the Cisco ASA or the Cisco Firepower, like the Palo Alto networks and the Fortinet and FortiGate, all these can also be deployed on Azure, even as you use them on-prem. The same way you use them on-prem is the same way you can get to use them in the cloud, just by you going to Azure Marketplace and then make a subscription for either of them and use them this very same way you use them. So the interfaces, the feel, the results is still the same as when you are working on-prem with either of all these different firewall solutions, right? So the network security group also is, I believe a lot of you are aware of the network security groups that you can use to filter what goes in and what comes out from your VNet, right? So that is still there, and you have the ability to use it to do your security and filtering as you. All right, so routing. Another capability of Azure Virtual Network is the ability to route traffic the way you want it routed, right? Now, it's not enough for us to say we want to just use the default routing process that Azure has made available, right? You can go the extra mile to say you want to customize the way your traffic flows in Azure, right? So you have the ability to use the route table, you have the ability to use BGP tables to be able to determine by yourself the way you want your traffic to flow. So you can override the default Azure routes, they override the default Azure routing table that it presents to you, and decide to say this is the way you want it to be, and as against the other way, I need you to flow this according to this part. Probably from your own experience, you feel, oh, okay, this route is shorter for my traffic. It helps reduce latency. It helps with whatever reason, right? You have the ability to override whatever it is that Azure has as a route, as a preferred route, as against what you will want to establish for your organization. All right. So still now, these are the various capabilities that Azure Virtual Networks gives to you as an entity, as an enterprise, to be able to do use Azure networks in whatever way, shape, or form that you want to consume your workloads in the cloud and the likes, right? So from there, we are moving into virtual network address spaces. Now, we all just by nature, the simplicity of Azure is such that you can easily pick up IP addresses on Azure, or even dynamically, right, without necessarily understanding what is at the background, right? So it's possible for you to consume all these things without knowing. But if you want to be deliberate and intentional, which is the reason why we are looking into this course, is our ability to be deliberate and intentional about our network designs. Because if you lose that control of how your network is designed, you tend to have problems once your network begins to scale to some certain extent, right? And the virtual network is nothing but your IP address allocations and managed properly, right? And that is what we want to look at in this segment of the class. Now, IP addresses and subnets. So you can have multiple virtual networks created within a region and within a certain Azure subscription, right? You can have as many networks as virtual networks as you want, right? All within a region. Now, and subnets can be created within that same virtual, many as subnets as you can. Now, we are talking about the network, and then we're also talking about the subnets, right? So what is the difference between this network and then the subnets? The IP address that is allocated to you, or the network itself, is it's a block of IP that is allocated to you, and you are expected as administrator to be able to allocate those IPs address to your resources, to your resources the way you want to it to be allocated. You have full control over that, right? And your control over that simply means the management of those IPs in terms of allocation or in terms of your design is left for you to decide. Azure will help you manage once you have allocated. And it is quite important for you to pick that block and then chunk it, right? And that is where subnet comes in. You have a certain block that is assigned to you, and then you chunk it based on your requirements, based on your needs in different networks that you are designing, right? So for a typical example is what we have on the screen right now, right? You have about 3 different networks designed here, right? And you will see under each of the networks, there is a big address space over there that is 10.1.0.0/16. And then there is another one which is called subnets, right? It is a chunk of the network address, IP address, that has been allocated to you. So you chunk it for different resources to use, for different regions, or whatever it is that you want to do, or different segments. It depends on you, right? That's how you want to go in your allocation. We'll look into that, how you can effectively design your network and assign your IPs appropriately. That will help you, that will create sanity to your design, and sanity to your network and your IP allocations, right? So in Azure, there are 2 sets of IPs. You have the private IPs and the public IPs. Now, the private IPs are IPs that are not routable to the internet, right? You cannot place them on your browser and expect them to resolve to any web page or whatever it is, right? They are not routable to the internet. An example of them is this 10.0.0/8 and then 172.1.6. So we'll go into what this 10/8 or this 16/12, we'll go into what they mean much later, but just have this understanding, and then we'll move on, right? Okay, so the 10.0/8 network is a private IP address that you don't need anyone to assign it to you. You can use it the way you like, right? So long Azure makes it available to you, right? Whichever one, either the 10.0 network or the 172.16.0.0 slash 12 network, or 192.168.0.0 slash 16 network also. So these three IPs are IPs that anyone can use within their network, within their resources. You don't need a third party to guide you or to tell you or to allocate this to you, right? Once you are on Azure, Azure will give you either of these three IPs, which you can then use to assign IPs to your resources in the cloud. Now, despite the fact that you have the rights to these IPs, there are some other IPs that are reserved, right? That you cannot allocate, that you cannot use, you are not expected to use. An example of them is this 224.0.0/4, which is a multicast IP address, and then the 255.255.255/32, which is a broadcast, and this 127.0.0/8, which is a loopback, and 169.254 slash 16, which is a link local address, and 168.63.129.16/32, which is for internal DNS for Azure, right? So these are reserved IP address that you cannot use as by yourself. You can't use it. Azure will not allow you to use it, right? And then there are also other reserved Azure IP addresses, right? So that you have the right to use all these IPs are here. There are 5 of these IPs that you cannot use. One is the network address, which most of the time starts with a .0, and then you have a .1 of whatever of these IPs, whichever of these IPs, the .1 of it is reserved by Azure for your default route, right, for a default gateway. And then you have .2 and .3 that is also reserved by Azure to map to your Azure DNS, right? So you use that for your Azure DNS, while the 255 of it is assigned to your broadcast address. Now, this is given to you with the mindset of the fact that you are using a /24 IP address. But if you are to use more than a /24 IP address, then it might not necessarily follow this order, or by the time you do a subnet, this will get to change, right? Things will change, to take a different shape. But all the same, by default, these are what you should expect in your IP allocations with Azure. Now, since we're here about our IP address, we'll be talking about IP address so much. So let's go in depth a bit, right, on what the IP address is all about, right? So you will notice, right, for every IP address you have is divided into 2 portions, right? There is the network and host portion of every of the IP address. Let me pick up my pen. Yeah, my highlighter. For every IP address you use, or that is assigned, there is the network aspect and there is also the host aspect, right? The IPv4 is 32 bits hierarchical. Those are good for theories, right? You can read that up. But what we are looking at, right, practically, is the fact that we have, for every IP address that is given to you, there is a network portion and there is also a host portion. You need to know as an administrator which part is the network and which part is the network and the host part, right? So for you to know which part is this, then there is another tool that is used in helping us understand or establish this separation. And what is used is what we call a subnet mask. Subnet mask is what we use to help determine where our network is and where our host is. So what is a network mask? Network mask basically is used to help identify in the IP address that is allocated to us what is the network portion of it and what is the host portion of our IP addresses. So for a typical example is what you have here right now. We have this IP address, right? 192.168.10.10, right? This is 10.10. Let me switch to maybe an Excel sheet to be able to sorry, I had to do some. All right. So if you have an IP like this 168, I want to do a bit of separation. 100.10, right? Now, this on its own like this does not tell you what is the network portion or what is the host portion of the IP. This is just numbers, right? And you know your computer does not know decimal numbers. All your computer knows is just bunch of zeros and ones, right? But how do you now tell the computer that, oh, this bunch of zeros and ones that you know, there is a part of it that is a network, while there is a part of it that is a host. Now, what do I mean by a part of it is a network and a part of it is a host? Now, it's just like when you say network portion, right? This it can be likened to a street. If you enter into a street, for example, your street there is the name of the street, right? And then there is the numbering of the houses in the street. There is a name of the street and there is a numbering of the houses in the street. The host portion is the numbering of your house, is the numbering of the houses on the street, right? While the network portion is the name of the street. Let me use this. So let's say this will be name of the street, the name of the street, while the host portion is the numbering of the street. So the same way you see that every street has a name, your network is classified as or can be likened to a street, right? So that you know the street does not mean that you know the number of the house you are looking for. So you need to have a way to be able to know the house you are looking for. And that is where the numbering of the streets comes in, or numbering of the houses on the streets, right? Numbering of the houses on the street comes in. So the same way in binary, because for example, if I convert this to binary, right, this is all you will see. This is all you will see. And then here is the computer trying to understand what all this, let me do this. Now, all these strings of zeros and one is what the computer sees as this, right? This is what it sees. But we'll then need to find a way to tell the computer that, oh, in these sets of strings that you have, at this point, which is this point, this is where the network portion, which is the naming of the street, ends. And then this other part is where the numbering of the street belongs, right? So that is where your subnet mask comes in. So subnet mask is what helps distinguish between your network portion and your host portion of your IP address, right? The reason why we are going in depth into all this is by the time we get into segmenting or chunking your IPs, so that you can be able to, by yourself, whether it is done automatically by Azure, at least you also understand what is happening with whatever it is that Azure gives you automatically, right? So now this is the network, right? This is the network. But now we don't even know where our host resides, right? So that is where your subnetting comes in. Subnetting is represented by these strings of numbers also. Now, is represented by this. So this is network, or let me say IP address. This is IP address, and this is subnet, right? Or your subnet max. That is the right word, right? Your subnet max is this. Now, so the combination of this IP address and the subnet max is what gives you a complete TCP IP protocol, right? So if we convert even this also into binary, it is not different from all this that we are seeing. It is just a bunch of ones and zeros also. So what happens in the back end is the fact that the system begins to do what we call ANDing, right? Which is comparing bit by bit, right? One by one, comparing this set of bits, right, against this set of bits to find out where there is all where the subnet bits ends, which is the last one here. Looking at this column D, the last one here. Oh man, the formula is messing things up. Let me paste as numbers, paste values, right? So it's looking for where this last bit resides. Where this last bit resides, as against with this, tells it where the network portion ends, right? And then any other thing after this last bit is classified as a host bit. So that is how that your so if we are to put it together, so if you copy this and then paste it, let's paste it somewhere else. Oh, let's paste as values also, and then we comparing that with this. So you begin to see that your ones and this one here under this subnet, under your subnet bit, ends at this last zero, which is here, right? So automatically that tells the system that this is where your network bit ends, and every other thing that follows will be classified as your host bits, right? So this is 10. Tomorrow it can be something else. It can even be 100. So you can even have 100 here tomorrow, and then the system will need to find a way to be able to separate your network bits from your host bits. And it's all done using what they call the subnet max. And the subnet max uses that by comparing where its own ones end as against where the zero begins, right? So wherever its one ends, it is compared against where whatever value is given at the IP address side of things to be able to know where the host bits will then begin. So that is subnet max, right? And with the subnet max and your with a subnet max, you are able to identify where the network portion of your IP resides as against the host portion. Now, in a situation where you have, now this that we have done is, if you count the number of ones here, they will be equal to 24. Because if you check out this first one, the total number of ones there is 8. This one, the total number of one here is 8 also, and here also a total number of 8. And if you add up all of them together, it will equal 24. And that is where you got that /24 that we have been talking about, the different slashes that we have been talking about. So whatever slash it is, if it's a /8, right? For example, so if I to copy this again and then do another one here, right? If I should change this to a /8 simply means that the number of subnet bits I have is just 8, which is here. Then every other thing is 0, 0, and 0. That is what a /8 means. So we are essentially just counting the number of network bits to be able to determine what our subnet max will be. So invariably, if we are to convert this to decimal, it will be 255.0.0.0, right? So that is how all these things are achieved, and that is how they are gotten. So they are not just numbers that one is just throwing anywhere or just allocating it without. There is a methodology behind it, and there is a goal behind it. So you can see the same IP address that stands as 192.168.100.0/8. The same IP can also go as 192.168.100. The same 10/24. So if we have, so I want to do a bit of comparison, right? Just give me a moment. We'll do a comparison here. We want to do a comparison here. We want to do a comparison here. So we want to do a comparison between these two. You can see that the same IP address is here as 100.10. The same IP is here as 100.10. But now we now have this one as a /8. We have this other one as a /24. So how do we know which is which, or how do we know which of the networks we are referring to? Because this will give us a 255.255.255.0, while this will give us, let me insert something here, 255.0.0.0, right? So you will have something like this, and then if you are not aware how these things are done, you will just look at this from the face value and say, oh yes, it is a /24 IP address, because your mind has always told you that once you see 192.168, it is always a /24. But it's not true. You can have a 192.168 100.10 or 100.anything and have it as a /8. And then you have another, the same IP address as a /24. All that is required to be able to know which segment or which network either of all these belongs to is to check from the subnet max. And that is where this subnet max is very crucial in your use of IP. So if you have an IP like this and then you forget to describe or you forget to include a subnet max, you have essentially given yourself a problem, because whoever it is you gave that IP to will just look at you and then is wondering, okay, is it a /24? What subnet max does this IP belong to? And remember, we said your subnet max helps you to identify the network that that IP belongs to. So, for example, this belongs to a 192.168.100 network, while this belongs to a 192 network. So this network and this network, they are different. How do we know that they are different? Is by their subnet max. So when you see an IP, don't be too quick to rejoice that you have gotten an IP address. You need to know the subnet max that IP belongs to, right? And that is what will tell you for a fact which network it belongs to. So that is what IP address and subnet mask, that is the relationship that they carry, right? IP address is used for identification of your network to your enterprise, to your to the world, while the subnet mask is helping your IP address tell the whole world where the network resides and where the host resides in your IP allocations. All right. So that's just to bring about a deeper understanding from that side. Now, then there is also another concept that we need to also take a look at, and that is what we call subnetting. Now, subnetting involves dividing your network into smaller IP spaces. Now, we were working with an IP just now, which is this one, /8, okay, /8 and then /24. Probably, let's assume that is the IP address that Azure gave to you. And then you now have, oh, you looked at yourself and you say, oh, my organization requires more than this single IP that we have. We have this IP is a /8, but we need more than this IP address to be able to do what we want to do or allocate our addresses properly for our resources. So probably you have in your organization, probably you have like different well, I say department or something, right? Probably you have the account, you want to separate the account department from the engineering department, for example, and then you have your sales units, right? You want to create different VNet for all these different um, departments, right? You want to create different VNets for them, right? But Azure will only allocate just one IP address per VNet, right? It will only allocate one. And then here you are having to, accounts cannot just use all your resources cannot just be in one single broadcast domain, right? You need to chunk it so that you can allocate these different IP addresses to different functions in whether like for example in your account maybe they have databases, they have file servers or something, and then you have maybe a print server or something, and then some other things like that, all inside your uh, um, account VNet, right? And then you are only given one block of IP. Let's assume you are giving this IP here, right? This is the IP that was given to you, and here you are having to split that IP to these three different VNets or subnets that you have in your right? So now what then do you do? Basically what you are expected to do is what we call subnetting, right? That means you take this big subnet and cut it into smaller parts. You cut it into smaller parts, and then you allocate those smaller parts to these various entities the way you like. Now, if you we'll first of all talk about how to do subnetting, and then we'll now go into how to plan the network, right? Now, because you can allocate your IPs and then you have problems based on the fact that you have IPs that are not properly assigned, right? It's not that Azure is not giving you the IPs, will not give you the IPs, will not allocate the IPs. All those will be done, but you tend to start having issues with proper summarization, proper organization of your IPs with time when you don't design your network properly. So subnetting, what do we do? Now we have a single block of IP, and then we want to split that block of IP into three parts, right? Which is this. So let's permit me to get rid of this for now. So what do we do? This is the IP we are giving, and it is a /8, right? So first thing first is you need to know how to do this subnetting. Though on Azure, you can easily go to Azure and then just pick a subnet, right? And it will be allocated. But what if you say you want to allocate these subnets in a certain style or in a certain way, that because of the fact that you have a goal at the back of your mind. So let's assume you want to split this IP into 3 equal parts, because you have need of 3 networks, right? So you say you want to divide it into 3 equal parts. But now, so this is how you do it in net. Go about this. First thing is you ask yourself. There is what we call a subnet table. You create a subnet table to be able to achieve this, right? So let me show you a typical example. This is a typical example of a subnet table that I built. So how did I do it? It's just understanding the fact that every IP address, so there's always an increment of 2 for every. So this is the subnet table I'm just trying to build, right? So 32, 64 times 2 is 128, times 2 again is 256, right? So minus, yeah. So this is the table. Let me reduce it a bit so that you guys can see it better, right? Now, this is the table, and then let's name this your IP address, right? Or no, this is your network, right? This is your network, and then you have the hosts. Remember, we said for every subnet there's always the IP, and then there's a network portion and then the host portion, right? So you have this is your network, right? And then for the hosts is still the same thing but in a reversed manner: 128, 64, 32, 16, 8, 4, 2, and then 1, right? So this is then lastly is what we call the subnet, or either, yeah, the subnet, right? So here now, because we are dealing with a /8, it's better you always start with the class, the super class that you're starting from. So here you have /8, and it will keep increasing to 9, then 10, /11. Remember, we said your subnet is essentially the number of network bits, right, in the IP address, the number of network bits, right? And that is what we're essentially counting here, right? We started with a /8, which is a super class, which is a class A IP address, right? This is a class A IP address, right? Which is a /8. So because we are working on class A, and then what we're having here is just this thing. We don't need to go too far. I don't want to take it into too much complex this thing. Try to bring it down as much as we can, right? So as you move, certainly the number of bits will be increasing from one octet to another octet. So that's where we're having these increments here, from 8 to 9 to 10 to 11 to 12, then 13, then 14, then 15, and then finally 16. So you'll see that this is a total of 8. Remember, when we're doing those 111 stuff, we said they are a total of 8, remember, right? So this is 1, 2, 3, 4, 5, 6, 7, 8. Is it 8? Yeah, 8, but I think I overcounted. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So that's what it is here. So with that in place, we then need to, so now, yes, we said we are looking for 4 networks, right? So if you are looking for 4 networks, you come to your table, you find out that, oh, your 4 networks, this is where the number 4 resides, or rather you're looking for 3 networks, right? But on this table you don't have 3, but you have 4. So, and your 4 includes 3 is included in your number 4, right? So with that, you select 4. The last one, that is the last the 4th network, you can keep that for any time for expansion or something, right? So this is the area you need in this your subnet subnetting chart or subnetting board, right? This is what you need, because this has told you the number of networks you are looking for, which according to your requirement says 4. And then it has given you the number of hosts that you will have um, per network, and then the subnet max that will be that this each of the networks will belong to, right? So with this now, this tells me that I can begin to allocate IPs like this for this network based on this requirement. Or let me pull this out and then pull this out. Now, if we start from, because certainly this will start from dot zero, so just permit this will start from dot zero, right, /8, right? So we are no longer doing /8, but we've been told that as our subnet max now is a /10, because we want to break down our /8 into 4 parts, and we've selected number 4, and number 4 give us a subnet max of /10. Now that will invariably mean, remember when we did our binary conversion of our, right here, I want to show you some more things, right? How this also comes about, right? Let's move this out of the way. Right now, this is your IP conversion, the original /8 that you were given, right? This is what it is, your /8, the original one that you were given. But now we now want to expand that /8 into we want to create more networks, right? So that we can feed those networks into these different subnets that we have. Now, I look at this and then I say, okay, our requirements is that we need 4 networks, and we've picked up 4 networks as a /10, meaning that all that is required now is to do our binary conversion based on our subnets. And remember, we said subnets, this /10 means 10 network bits. Remember, if you copy this now, which is, this is the original /8, right? This is the rendering of your /8 with this number of bits, which is 8, as you can see. So invariably meaning, for us to now have a /10, which is what we're asked to do now, is we need to add more network bits to this. And that will mean that we'll have something like this. Let me copy this. And then we'll have something like this, where we have 1, 2, 1, 2, 3, 4, 5, 6, right? We'll have something like this, because now we have borrowed more network bits from the original subnets that we had. Let me okay, I want to show you all these things bit by bit. So the original, let me see if this will stay. Is not. I want to. let me see if I can paste as copy. Let me change this instead of number. Let's have it as text, so that you can see. I want you to see this that I'm doing. Okay, now it's as text. So 1, 2, 3, 4, 5. Is it 8? Right now, good. It's 8 now. So this is our original /8, which was what we're given in our requirements, right? And then our subnetting has given us a /10, meaning we need to add 2 more extra bits. So we need to convert 2 host bits from this /8 to be able to get our /10. And for which, if we get to do that, invariably meaning the number of host bits will reduce. And that reduction is what helps us achieve the subnetting the way we want it to be. And this will then take us to /10. So instead of us having, initially, we used to have, I need to keep moving this thing down. Right? Initially, for this as /8, we used to have something like this, 255.0.0.0.0, right? Right? This is what we used to have before for our /8. But this time around, based on the fact that we have borrowed 2 network bits from it, it has now changed to, which is what we did here, it will now change to something like this, 255.1. Sorry, just give me a moment. I'm trying to calculate something here. Sorry, let me pick up my calculator. I need to do addition. I'll show you what I'm doing. Don't. Calculate. Where is it? Calculator is not coming up. Okay. So your first bit here, which is 128, right? So 128. This is. We need to hold on. Just give me a moment. I'm trying to get the. This is yeah. Sorry. This is 1 plus. So 1 plus 2 plus this gives us a total of 6, 7, right? So 7 will be 2. Sorry, just give me a moment. My calculator is not coming up. I want to use my phone to do the calculations. So that is 128. So here will be 255 dot sorry. Yeah, that'll be 128 now. It should be 128. 128.0.0 as our /10 subnet max, right? Let me quickly confirm that. Max. Sorry. Just quickly give me a second to confirm that. So basically, that's why am I having. Yeah, sorry, 192, not 1. Yeah, that's 192. Sorry. All right. So that is the subnet, the new subnet that these different networks will then be carrying, right? And then the next is after you have gotten the subnet mask, you have gotten the subnet mask that you want to use, right? So though from this point, you can easily go to Azure and then Azure and pick IPs slash 10 IPs from Azure, right? You will see it once you start configuring as the required subnets for these different networks. So from this point, you'll be seeing things like, so if we then want to design this now, we'll be seeing things like your first IP address will be around 192.16. It might not be 168 anymore. 192.0.0.0, right? And then you have this plus 64, this plus 64. So this plus 64 will then give us 192.64, sorry, dot 0 and 0 there. And then the next one will be 192.128 0.0, right? So this will now be the new subnet, the new network ID that these different subnets will carry, based on the fact that you have chunked your /8 into these smaller groups, right? And then you can continue to, so with this now, you can decide to even further divide this into smaller chunks too, all based on the way you want it to be. All right, so that is the concept of subnetting and subnet max, right? So we'll then go into IP planning. Now, you will notice when we talked about this, right? You will notice something that it's more or less like we are trying to summarize or build this network in a manner that we can easily identify the networks or identify the different IP address based on allocations, right? And in a situation where you have a very large network, right, you want to be able to, at a single glance, know where a certain type of IP is coming from, or where a certain group of IPs they are coming from, right? So, and again, probably in the course of building your network, you want to do a bit of filtering, right? You don't want traffic from so and so to be able to enter this so and so network, right? A certain VNet, right? So you can do filtering when you have that level of control of your IP. So in a situation where probably you have a network, right? Let me use this. Maybe you have a network, you say 192.168 168 10.0/24, and then you have, maybe this is okay, let me use /16 instead of 24, right? 0.0/16, which is what most of the time you tend to always receive from Azure, /16, right? You have this IP address, and you then have another one of 192.168, or let's say 167.0.0/16 also. Now, no, let's maintain this, right? And then you say you want to divide this among all your resources and your different VNets that you have, the different networks that you have, virtual networks that you have. Then you now decide to say, okay, maybe for our maybe let me use accounts, right? For our account network, we use 0/24, and then you go to the next one. Okay, you notice this is a /24, right? Not a 16 anymore. So we've done our subnetting mentally or by default from whatever it is that Azure has given to us, right? Maybe this is account, or maybe this is from your London office, right? This is London office, account department, and then you have engineering, right? And then you have developers, right? Then you have your QA team here. You have your, who else? The SRCE team also. This is for the London office, right? Right now, this, and then you, in the process of allocating, you just picked the next available IP, right? You just pick the next one, and then you say this is .1. Then the next is the next available one is also is .2, right? And then the next one is .3. Picking like that, right? Sequentially, right? Without, yeah, it will work, right? Because you are just following a certain sequence as it's being allocated. So long you have it in the subnet, under the same subnet, right? The same block of IP, right? And then the difference that you're picking is still, it's okay. There's nothing wrong in this. Challenge will then come when probably you want to say, how do I, you want to say, this is for your London office, right? And you go to, you establish another, will it be a region now? Yeah, probably. And then you say this is Accra, right? And then the same thing gets to happen this time around. This is should I use this? Okay, let's go on. Let me use the 192.172. I'm just thinking 172.16.0.0/16, right? This is another IP, and then you went ahead the same way, allocating your IP addresses just the same way you were doing before for your /24. Then this is one, and here you have oh, sorry, this is one. Here you have this. So you have .2 here, you have .3 here, you have .4 here, then maybe 5 or something, right? You have .5 here. Now you are not trying to do something, and which is, maybe you say you want all the engineering network, right, to be able to talk to the Accra network, right, the account network in Accra, but not the developer network to be able to reach the account network, right? You don't want such a thing. You only want the engineering network. So this is engineering network in London. To be able to speak with the account network in Accra. Now, because you have, now this is quite easy, right? Because it's already in a sense summarized. It's just one, or maybe you want your engineering and then QA, right? Or engineering and developers to be able to talk to. Yeah, I think that would be a better yeah. Probably this is what you want, and they are the only ones that should talk to the account units, right? And then you have this kind of IPs, This is still okay because it's quite small, but once you have it in a larger sense, that's when you start seeing what it is that I'm talking about, especially when they are now, you have different dimensions of the IP segmented in, subnetted in different ways, right? Then that's when you get to see what I'm talking about in real play, where you are not, for this kind of a thing, right? Since they both start with 192.168, in a sense, you'll be assuming that, okay, everything that is coming from, I can just do everything starting with 192.168. I can just use that to filter this and say drop all this or permit all this, right? It will become a problem when you don't design your IP properly, when your IPs are scattered. In the process of doing that kind of a thing, you will not be able to summarize your IP address to make filtering easy for your, both your NSG or your network appliances or whatever it is. They will not be able to work effectively, or they will be working over time when you have to be doing this manually, one by one, when you don't have consistency in your IP design. So for this kind of a thing, if we want to summarize this now, this is 0, 1, and 2. 1 and 2. Because 0 is the leader here, you can't summarize effectively. You have to be doing it one by one as it is like this. That means, and you know, the filtering mechanism starts reading your filters, right, from top to bottom. That is one by one. They read each line of the policies that you drop on your policy table, one after the other, from top to bottom. Now, instead of it having to read through an IP address once, if you had summarized, you tend to see that the same policy map is being built for individual IPs one by one. Why? Because you did not plan your network effectively. And that is where the concept of understanding subnetting and subnet max come into play, so that by the time you are picking an IP address, or you are telling Azure to supply you an IP address, you have a way to let it know that this is the right IP I want, this is the way I want it, and this is the way I don't want it. That your IPs is just coming to you 1, 2, 3, 4, 5, 6 does not mean that you are being effective, right? So you need to plan your IP addressing properly to be able to deliver on the task that is given to you as a network engineer, right? Or whether network engineer or an administrator, right? So you need to take cognizance of these IPs. You need to take cognizance of the fact that, okay, now if you look at this on the screen, for example, we have these various subnets. Like from VNet A has an IP address space of 10.1.0/16. It also has an IP address space of 10.0/16. Now, these are different IP address spaces. Yeah. Okay. So these are different IP address spaces that you need to manage effectively, despite the fact that it's just automatically given to you. So understand that you need to have a solid hierarchical structure of your IP addresses, even as you go about designing your IP or using your IPs. So going into coming back now into Azure, so we have different subnets. Azure has the ability to, whatever IP address that is given to you, it can break it down into different subnets based on whatever way you want it, or you want to make use of, right? And whatever it is that you are using in a certain subnet is a function of the number of end devices that will be there, right? So you need to also have that at the back of your mind. How many endpoints do I need in this segment or in this subnet, right? That will determine the subnet max that you allocate to that subnet, right? And remember, when you are allocating your subnet max, always have it at the back of your mind that you need to have a structured way of carrying that out, right? So private IP allocations, for every private IP, your virtual machines will need the NIC cards, while your load balancers will also need private IPs. Your application gateways also gets to make use of private IPs. So this is how to create your virtual network. So just to okay, right. All right, let's go into, so your virtual network. How do you create it? So your virtual network can be created at any time. You can add networks to different virtual machines, right? And so for every address space, there must be at least a minimum of a single subnet. We'll see how to go about that right now, and then ensure that in your use of your IP address or the allocation of your IP address, ensure you don't have overlapping IP address. What do I mean by that? So, for example, right, you should ensure that you don't, once you have allocated like this 192.168.0.0/24 to a certain VNet or to a certain subnet, you don't go and use that same VNet subnet, right, again for another resource, right? Don't do that. Or probably you allocated a /24 this way, right, and you got to this place, you then change it to a /16, right? You change it to /16, right? It's overlapping. Or probably you now pick this and then you say /16. In your mind, you are feeling, oh, 192.168.1.0 is different from 192.168 and 192.168.0. It is different, but the subnet max is overlapping because 16 is bigger than 24, right? You can find 24 inside 16, so it's inside. So this is what we call an overlapping IP address. So you must watch your IP allocations to be sure to ensure that you don't have overlapping IP address in your network designs. All right, so if we are to go into let me check where all right, so now moving into public IP addresses. Now we've talked so much about private IP addresses. The concept of subnetting is still virtually the same, right? But for public IP addresses are basically IP addresses that are routable to the internet, right? These are IP address that you can allocate to your resources that needs bidirectional traffic communication, right? Bidirectional meaning those on the internet needs to reach out to it, and also maybe the server also needs to reach out to whatever resources also in the internet. So your public IP address gives your resources ability to be seen on the internet and to be reached on the internet, right? So both inbound and outbound traffic is, you can control all those things with your public IP address allocation. So we said something here that your public IP address, you can, the same way you dynamically and statically assign a private IP address, you can also do the same thing with your public IP address. So you can have a pool of IP address and then tell Azure to allocate those IP addresses to your different resources automatically. So once you create a resource and then you attach a public IP address to it, it works, it sticks to that resource for the life cycle of that resource. So if that resource by whatever it is, you get to delete that resource. Once you delete that resource, that IP address is freed up for any of your other resource to use if you still want to continue using the public IP address. Unlike the um, uh, so sorry, dynamic IP address is such that you can automatically assign, but your static IP address, public IP address, is attached to your to a certain resource. Whatever resource that you attach that to, it sticks to with it for the life cycle of that resource. And the moment when you delete it, that's when it lets go. But for dynamic allocation of IP address, is done in such a manner that once you turn off or turn on or something like that, that IP address is gone, and then you need to and a fresh IP address will be allocated to you. So, but if your resource is such that you need it to be static, right, then it's better you use a static IP address. For a typical example of a resource that you want to give a static IP address is more probably something like your load balancer or something. Then your web servers and the likes behind can then have dynamic IP addresses and the like. So that is public IP. So dynamic and static applies even for both private and public IP addresses. So it's not limited to just public IP addresses. It operates both ways. So these are the different properties that you can allocate. Just some that you can allocate public IP addresses to, and then some that are dynamic and some that are static. So, for example, we said your firewall can only be given a static IP because you don't want the IP address of that firewall. Probably you create a VPN tunnel across the firewall, right? You will not want a situation where anything happens to the firewall, right? Maybe it goes off and comes on again, and then the IP address has changed. At that moment, having to set it up again becomes a problem, right? So you need to know when to apply a dynamic IP address and when not to, right? Dynamic is easy, is sweet, but there are some resources that it's always better to have them as static IP address. The same thing with your NAT gateways. So this is how to configure your public IP address. Just go to your Azure resource, search for public IP address. You select whether it's IPv4 or IPv6, right? For now, I think IPv4 is what is Azure allocates, right? But you can get an IPv6 too. So the SKU for public, as at now, standard is not longer usable. No, sorry, basic is no longer usable. Standard is the only one that is operative now by the time you go check. So you also have your global tier and then your regional tier. Global tier means that your public IP address can be seen across different regions, right? But for a regional public IP address, it just stays within that your region. So you can use it for global. You can use it across several regions, right? So that's how to create your. So now let's go to taking an exercise. Let's take an exercise. We want to see how we can create a virtual network on Azure and then create some subnets, right? So this is an exercise. So let me call up my Azure. So this is my portal, and then so first thing first, in creation of probably let me take this off the screen here for now. Let's take this off. Okay, it doesn't want to go. All right, I just want to see what are the tasks that will ask to do. All right, so first thing to create a virtual network is just first thing is for you to search for that virtual network, right? Okay, so probably if you already don't have a resource group, right, you can start by creating a resource group first of all. So let's just follow what it is there. It says we should create a resource group first. So you look for a resource group. Let me try and clear off what I've done before. Let me delete all this so that we'll not have duplication of names. So delete. Yep. Sorry, is it gone? Yeah, I need to also delete all these other ones. So I need to delete these vignettes because we're going to see the same name played out that way. That's why I want to get rid of field. Uh, okay, so let's go back to let's delete the VNets attached to the resource group first. Let's delete those first. Or resource not found. So I think it has gone. Let me refresh and be sure. And be sure everything on that is what's happening. You're taking my time. You're taking my time. Oh, okay. This is another thing that I created too. Okay. So let's it's your Azure portal. So you just log in with to azure.com. If you don't have an account, you need to create an account with Azure. That is azure.com. Yes, exactly. So you go to azure.com, then sign in. Once you sign in, then you'll be able to see all these things that I'm seeing too. You'll be able to see all that I'm saying too. Is this thing ready? Okay, so probably what I'll just do is instead of me following the names we have here, we'll create our own names and then so that we don't take too much time. So I want to create a resource group. Resource group helps us house all the different resources that we want to. It's more or less like a management process, right? Helps you manage all the resources in a structural way, right? So if you have different resources for a certain group of people, you create a resource group, what they call a resource group, and then all those resources, everything that you're doing will be inside that container that will be for just those group of people. So for example, we can just call this our engineering team, right? And so this is my Azure subscription. You need to have a subscription, right, before you can make use of Azure. So you select your subscription in case you have multiple subscriptions, and then you create a resource group, and then whatever region that you belong to, and so you create this, just a summary. You create yeah. Okay, so the resource group is created, the engineering. So if I refresh, there's my, yeah. So we have our engineering resource group, right? So I will just be picking different names as we go on, right? So please, I'm not following the script anymore. So this is so it's more or less like just a container, right? Having that you can put in different things into it as a logical way of grouping things, right? So we have engineering resource group, right? And then you now have so now let's create our VNets that will be attaching this attaching to the resource groups, right? So you click on create virtual network. I think I'm faster than the way this thing is. Okay, so this is one resource group, or the resource group we created is engineering. So we want to do everything engineering inside here, right? This VNet is for the engineers to use the same way you have your developers and the right and the likes, right? So we want to give our virtual network a name. So it's a network, remember. So you can just go ahead to say engineering VNets, right? Engineering network, so that at least you can always remember that this is for the engineers. Now, oh, sorry, there's something. So after back, back, back. So after creating your the name, the name is very important, and this name you should not have it used somewhere else, so that you'll not have this thing. So security, we will not be looking at all those for now. Then the IP address that is given here right now, I can change this into any IP address space that I want, right? So long, remember we give three sets of IP addresses that you can use: the 10.0.0 slash 0 network, which was what was given to me initially, or the 172.16.0.0 network slash 12, or the 192.168.0.0 slash 16. So all those IPs are the IPs that you can allocate or use um, as a tenant in Azure, right? So now this is the block of IP that I've been given, or that I've picked for myself, that I want to allocate to my engineering team, right? And here we now need to my engineering team is divided into, let's assume we have our engineering team as core engineers. We have them as core engineers. We have manufacturing engineers. We have research engineers, right? These are the three different engineering team that I have. So what I'm expected to do now is to split this my slash 16 IP into three, and allocate those three IPs to this individual, what we call now a subnet. So I click on add subnet. So the purpose of my subnet here is a virtual network here. So yeah, that is the first subnet I get to create. So we can call that. All right, let's just go on. Right. So I can decide to change the name. Right, instead of default. Initially, it's default, so I can change this to maybe let's call it what did you call it initially? Engineering. Let's say manufacturing. No. Let's use engineering 01. Engineering 01 subnets, right? So let's let's use 00 so that it will tally with the IP address that is here. So this is the IP address, right? It's an IPv4. This is the range starting from here, and it's a slash. So here, from my slash 16, Azure is giving me a slash 24, and probably that's not what I want, right? I don't want the entire 255 IP address to be allocated to this particular subnet. So what I can do is I can click on this drop down and then select from all these that is here. Now, if I click slash 16 basically mean that I want to use the entire block just for this engineering 01, and you can see that it's already giving you errors here telling you you can't do this, right? So instead, we can either use like a slash 24, which gives us 256 IP addresses, or we go lower to somewhere around a slash 29, which gives us 8 IP addresses. It all depends on the number of resources that you're anticipating will be on this subnet. Depending on the number of resources you're anticipating will be on this subnet, will then determine how you will go about your IP allocation. So if we pick ours, just for ease sake, let's just pick our slash 24, right? And then start So I'll start. You can start from dot one, yeah, and basically that's all that you need to do at least at this moment on this, right? So okay, I can't remember this. Right, so we've done for subnet 01, which is oh no, so my naming is wrong. I want to make it consistent. I think okay, so let's keep it consistent with the IP addressing. So this default, sorry, I think I need to change this to, instead of defaults, it has to be the virtual gateway. Yeah, the gateway subnet, right? Now, the next is I want more. This is not just so engineering 01, and then so the purpose all this you but you need to change this. So this now becomes engineering 02. So you will notice that Azure automatically just fills all this for you without you having to worry about the subnets, right? Because it just picks the next one, right? It just picks the next one, and therein lies what I spoke to you about as regards to your IP planning, right? Azure is just picking for me based on what it feels like. Okay, this is what is easier to pick as the next. But if I say no, I don't want this, right? I can also decide to say, let's go to 5, and then I tell this to go to 5, right? So I can skip. So there's nothing, it's not compulsory that I must follow it sequentially the same way it's just giving it to me. I can decide to pick. And if you don't have a proper IP plan, right, you will then start picking IPs that you cannot manage effectively, right? So these are the different IP addresses that we've done, and then you just click on create, and um wow, time is flying, right? So then you click on create, right? So with that, automatically you have created your VNets, you have created your subnets at a single go. But that does not mean that at every instance that you want to create a subnet that you have to go through all this process. You can, from an already established VNet, right, create more subnets as you will, and also get to delete subnets as you will. So you can expand your subnets into, from initially we started with just /24 for each. You can move your /24 to maybe a /23, or maybe a /22 or 20 even, right? So it's your choice, because everything is still within that block that you were given, the /16 that you were given. So if you go to our resources now, you see that our engineering network now has all these different subnets attached to it. So you can see, at least this gives you a a pictorial view of what has been allocated to you. So if you are to look for the subnets, right? So these are all the subnets that we have created under your engineering VNet, right? And these are the subnets. So from here now, if you have created maybe like a resource in Azure, and you say this resource is for the engineers only, so you come here and then you pick, you select for that resource, you select the engineering VNet, and then that resource automatically becomes part of this your engineering VNet, and then you need to pick a subnet that resource belongs to. So that is basically how Azure allocates IP addresses, and Azure Virtual Network is built, right? So there are still several other. So just like we did, you notice we did the VNet, right? And then we did the various individual subnets below it, right? So this is just a typical example of what it is that you will see. And we also verified by checking that the various subnets and then the VNets that we created, they are all in there, right? So there are other things that we still need to talk about, but I don't think time will permit us, but just let me run through as much as I can. Another interesting concept in Azure networking is what we call domain name resolution, right? That is name resolution. So in Azure, we'll be looking at, there are what they call the public DNS, there's the Azure DNS zone, delegation, and then private DNS. So basically, what is DNS? DNS is basically a way in which systems are named, right? A way in which systems are named. So whether it's a computer, whether it's a service, or whatever resource that is on the internet, that you just find a more human readable way, right? To name those things, so that one, instead of trying to remember 192.168.10 dot this 192.72, before, it is easier for us to remember her names, right? For example, my name is Barry. I don't need to think too much about it, right? We are in Azure. This is an Azure class. I don't need to think too much about it. I can easily remember names than remember numbers, right? And that is what your domain name resolution helps you do, is to help you achieve naming, easy way to name things without having to remember the IP addresses. And you remember, computer communicates via IP addresses, and your IP addresses also are even binary numbers, right? So it goes from binary numbers into decimal numbers, right? And then from decimal numbers, we are talking about domain name resolutions now. That is name resolution. So there are there's what we call the public DNS, which is the same resolution that is done over the internet, right? Then there is also what we call the private DNSs. Private DNSs is resolution done within your organization that does not necessarily need internet connectivity. All right. So something like internal to you, probably your servers, your switches, your routers, your access points, your printers, the likes, right? You can give them names internally with your own private DNS server that helps in doing your name resolution from IP address. Anything within your network that, or within your system, that requires an IP address, you can use a domain name resolution system, right, to help manage those IP address in terms of giving them names that can help you remember them quickly. So Azure does what we call the different records that can be kept on the DNS, like the host record or the alias records, different things entirely. So just to run through as quickly as we can, Azure DNS is used in hosting DNS domains, while the public DNS is used for your DNS services for your internal network, right? So one is internal, which is the private, and one is public facing, which is something that is facing the internet, right? So then okay, DNS configuration. So basically another thing that we need to understand is Azure itself is not a registrar, right? But what Azure does is to forward whatever it is that is delegated to it, right? So what you do in Azure is actually a delegation. So Azure helps manage what you have configured in a public DNS service, right? So the public DNS service exists that Azure will reference, right? But you need to give delegation or rights to Azure to be able to carry out that. And that is what DNS delegation is all about. Now we've talked about the private domain, so this is just within your own space, just within your network, not having anything to do with the internet. So Azure can help you do that kind of a thing where your IP addresses no longer becomes numbers but now letters that you can easily reference for identification's sake. Now, going forward, also there's also the cross-net connectivity pairing. Now, your virtual network has the ability. Remember what we said, that you can pair or communicate with Azure network, Azure resources within your network, or talk on-prem to your on-prem network, right? So those type of communication is achieved by what we call the Azure pairing. Now, the regional VNet pairing connects Azure virtual networks within the same region. So probably you have your resources, a VNet in one region, right? And you have another VNet in the same region, right? They are isolated because of the IP addresses. Each VNet is isolated, but you now say no, you want to connect them together. You want them to be able to send traffic from one to another, right? That is where your VNet pairing now comes into play. So you select a regional VNet, but if, for example, what you want to pair with is in a different region entirely, then you migrate. You need to change that your settings to what, a global VNet pairing. So these are just the benefits of your VNet pairing, and then this is how to go about setting up a VNet pairing. Then there's also what we call the gateway transit, right? This is when you want to connect um, 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 different virtual networks together, right? Through what they call a VPN gateway, right? And that's where the gateway transit comes about. So if you want to bring different resources together, like a hub and spoke network or hub and spoke design, right? That is one to many connectivity. You use a transit this thing. Still trying to. I think it's better we just stop over here to give room for questions. So I'm sorry, we there's so much to talk about, but we don't have enough time to, and we have a hard stop in the next 9 minutes. So I think it's better for us to just stop here, then probably continue some other time while I give room for questions, for any question. Kathy, are you there? Hello, Kathy. Okay. Yeah, I was proposing maybe I stop here as against having to give room for questions. What do you think? Your audio is down. Your audio is down. I think you're muted. Check your mic or something. Your audio is down. It tried coming up some seconds ago.
What about now?
Yes, better now. We can hear you now.
Okay, that was a great one. That was intensive and a great one. Thank you so much. Like you suggest, we can actually call it a day for today. But we are going to give room for questions.
All right.
Okay, guys. We've have Barry. Barry has taken us through introduction to Azure networking. Do we have any question? So the question I could see here, it's saying, how do I get to this UI you display on your screen? Raphael, we don't really know if you're talking about Azure. Okay, you're talking about Azure. Are you talking about Azure Portal?
Yes, I think that's what he's talking about.
Okay, so quickly, I will be sending you the link to Azure Portal. I don't know. I believe you have not registered before now, right? Just a moment. So this is a get started link for you to sign up for Azure. And for today's class, today's topic, I'll equally drop the links so you can go over it again and do the lab, the exercises yourself if you're interested. It would be great if you can go over the topic again. Today's topic was recorded real life. So even after this time, you can still view it at your convenience. So I've dropped the link. I believe you guys can see the link.
Yes.
Okay, just a moment. Next week we'll be having a topic called design and implement hybrid networking. I think I should drop that link as well so you can you can practice and go through it even before the class, which will be better. It will be easier that way because you're already familiar with some of the topic. It's with the concept that we are going to teach. So guys, any other questions apart from Raphael question? If there is no question, we call it a day for today. So, Barry, we are very grateful for having you taking us through Azure introduction to Azure networking. We hope to see you next week on continuation of the networking. I guess you're taking us through another topic, which is design and implement hybrid networking.
Yeah. Thank you for having me.
We are grateful to have you. Thank you so much. So, guys, do have a great week ahead. See you next week. Thank you. Bye from all of us here.
Yeah, bye.
Bye.
Bye.